Everyone, in this video we're going to go through the solutions to 3 past exam questions that focus on linear regression. If you do get yourself familiar with past exams, which you should, you'll notice that this turns up on every exam because it's on the study design. Usually you're given a set of data and you have to answer a bunch of questions. Now the questions are usually the same, so the more you do, the more familiar you're going to be with the types of questions that are asked. Most of these questions you should be able to ask. Sometimes they throw a curveball and you're like, oh, what's that? But for the majority, they're pretty straightforward questions. You're given a set of data and you just have to do a linear regression analysis on it. None of these have transformations. That's going to be covered separately. So yeah, just looking at things that like calculating the least squares line of best fit, interpreting your slope and your y-intercept, understanding R, your correlation coefficient, and R squared, your coefficient of determination, residuals, and just thinking if there's anything else, and describing a scatter plot basically in terms of strength, direction, and form. All right, it turns up every year. So let's get started, and hopefully after these 3 you can have a look at past exam questions and do them yourself, practice them yourself. All right, you can just go to the VCAR website, find the past exams, find the questions. All right, so just before I make a start, you'll notice that each question I've got a percentage written there. That just refers to the percentage of students who got it correct. So obviously the higher the percentage, the easier the question. That's only going to happen for this first question, the 2020 exam, I should say. The other 2, the NHT exams, that means the Northern Hemisphere exams, not enough students do them, so no statistics are recorded for them, only for the students who do it in the Southern Hemisphere. Anyway, let's get started. So question 6, the table below shows the mean age in years and the mean height in centimetres of 648 women from 7 different age groups. I've got our data there. What was the difference? So the word difference just means you subtract. Right? You subtract your highest number minus, you subtract your lowest number from your highest number. Between mean height, so we're looking at mean height of the women in their 20s. All right, so that refers to this value here. And the mean height of women in their 80s. All right, so basically we're just going to do the highest number and then we're going to subtract the lower number. All right, and that'll give you 10.4 centimeters. So answered quite well. All right, a scatter plot displaying this data shows an association between the mean height and mean age of these women. In an initial analysis of the data, a line is fitted to the data by eye as shown. All right, so looking at the scatter plot, and we've got a line there. It is not that necessarily the least squares regression line, it's just a line that's fitted to the data by eye. All right, describe this association in terms of strength and direction. So we've only got 2 things, so we just need 2 answers, and we don't have to put them in a sentence, just the 2 words. So the strength, it's clearly strong. All right, it's forming a pretty straight line and it's going down, so it's negative. The 51%, the reason it's so low is because students are used to writing 3 things. So you see strength, direction, and form. So this was actually done quite well by you guys. So the form for this, you don't have to say whether it's linear or non-linear. It's only asking for the strength and the direction. So we're just saying strong, negative. All right, so this wasn't given a mark if you also wrote linear or non-linear, even if it was correct. All right, it's only asking for strength and direction. So that's all you answer. All right, the line on the scatter plot passes through these 2 points. Using these 2 points, determine the equation of this line. Write the values of the intercept and the slope in the appropriate boxes below. And we've got to round the answers to 3 significant figures. All right, this was only worth 1 mark and it was poorly done, all right, only 23%. So before I answer the question, I'll explain what common errors students make. And this was also done in class. So not only was it badly done in the exam, but also badly done in class. All right, the error students make is they don't see this 20, and they read the y-intercept here. All right, so if you had 168, you're actually wrong, because that's not your y-intercept. You can only read your y-intercept when it's 0. You may have got the gradient correct, because you can do your rise over run with your 2 points, and then you use the incorrect point on your graph. Now, you can easily do this on your calculator, or you can do it doing a straight line. We've been given 2 points. We were told to use those 2 points. So if we used anything else, so if you went ahead and created the least squares line using the points on the scatter plot, you wouldn't get marks. All right, so you got to use those 2 points. Now, this equation down the bottom is in the form y equals a plus bx. All right, so we've got mean height and age. They're our x and y variables. But we can just solve it in our calculator. So if we're substituting in the point 20, 168, so that means, let me just do it over here. I might have to do it up here. So we've got 20, 168. So that's our x and that's our y. So if I substitute them into the equation, I get 168 equals a plus b times 20. And then I can do the same thing for the second equation, which is 157 equals a plus b times 85. And that looks like a 6. It's very hard to draw on the screen when I've got it up. I haven't got it flipped. All right, so with our 2 equations, we can then just put them straight into the calculator. All right, so just ignore all that other work I've got there. So when we're solving, you can use solve. We've got 2 equations. I always find when you're doing multiple equations, you can use this button here. And then you just type them in. So 168 equals, and you can use x and y, but if you feel like you're going to get confused, just use a and b. So a and b can be found not with the var, but with the ABC. All right, you can use your a and your b there. The only reason I wouldn't use x and y because it can be confusing. So unless you're 100% confident, I would just stick to a and b. A plus b times 85. And then we're solving for a and b, so we go a comma b. All right, and it tells us to round to 3 significant figures. So the first one is 171. And then the second one is -0. We don't count as a significant figure. And then 169. Now remember, if you do struggle with significant figures, because if you didn't round this correctly, you got the 171 and the B correct, you still wouldn't get that mark, unfortunately. So as I've shown you before, you can go to S round. And if you want to use it, I strongly encourage you just to have it on your screen ready for your exam or your SAC. So it's really annoying going down. So you don't have to clear your calculator before a SAC or before your, maybe for your SAC depending, but definitely not for your exam. So you just go S round, highlight your number, drag it down, and then go comma, how many significant figures? 3, and there's your 171. We can do the same thing. So if it's already on your screen, you don't have to find it. So, all right, so we're going to highlight that whole number. We can just go edit, copy, and then we're putting it in place of this number here. So we can just delete all that and put it in. All right, and there we've got the -0.169. You can also create shortcuts if you want for S round, just like, you know, sometimes you use the shortcut shift divide to do your fraction. You can do the same thing for S round. All right, moving along. The scatter plot below shows the body density in kilograms per litre plotted against waist measurement for 250 men. All right, we've got the equation and we have to draw it on the scatter plot. So this was not answered very well in class, and it was 41%. Again, the main issue is when you don't start at 0. All right, so some students would have drawn it at 1.195, which is not, you can't sketch it on here because we don't start at 0. So what you do when you're sketching, and you can do this for 0 as well, you choose your two endpoints, so at 60 and 130, and we substitute them in for waist measurement. So just get the calc back up. All right, just go back to the main screen. So let's substitute in 60 first. So 1.195 minus 0.001512 times 60. And I'm just going to do the other point. So we can drag that down, and the other end point was 130. Okay, so for my first point, when waist measurement is 60, I'm going to plot 1.1. Whoops. And oh, you can see, just thinking about what we're going up by each time. So this scale is a bit of a pain, but we're going up by 0.01 each time. So the next one's going to be 1.11. All right, so we're going to be kind of halfway. That's why it's halfway. So if you had anything between 1.10 and 1.11, all right, so usually in an exam they allow a little bit of allowance, if that makes sense. So anything between those two lines was fine. All right, and then the other one, 0.998. So that's pretty close to 1, so you can see that it's just below there. So you kind of want to be, I think they would accept if you were on the line or just below, probably not too far down here. Now, if you don't need to write the coordinates on there, because if they're wrong, you'll be marked incorrect. So just draw the line. All right, putting the points on there. If you've drawn the line incorrectly, but you've put the point on correctly, they're not going to say, oh, they got the right point and give you the mark. The line is what they've asked for, and the line is what you need to give them. All right, so just remember that, your two end points. All right, use the equation of the least squares line to predict when the waist is 65. This is such an easy question, but 73%, I can see if you're rounding to 2 decimal places, a lot of students probably just left it as 1.1. Has to be to 2 decimal places, so 1.10. So we've already got the equation in there, so we can just drag it down instead of retyping it. And this time we're substituting in 65. Or maybe they did 1.09. I would say the lower than what I would expect. 73 is not low, but lower than expected was because students didn't round correctly. All right, and then part C, also poorly done. When you think about it, you've got a better chance of guessing it correct because it's either one or the other, but in class most students wrote interpolating. So we're making a prediction for our, we're substituting in an X value. So when we're looking at the prediction, all right, so you're probably thinking, oh, we're going from 60 to 130. So 65 is within that. But it doesn't matter what your scale is. We have to look at what the minimum and the maximum are. So here's 65. So this point here is clearly above that. So let's say it's 69. All right, so 65 is not within the data set. So if we actually had all these points in a table, you would see that 65 was below our minimum value. So you're actually extrapolating, you're outside the data set. All right, so the scale, I assume, is what people looked at, and this is 126, so anything above that. So do take care with that, because you can see how easy you can get it wrong just by not looking at the graph correctly. All right, part D, interpreting the slope of the least squares line. So 44%, got it right. My mind is always boggled when this is not done well. So I would say 44% is not done well. You just have to get the sentence correct. So what changes is so body density is your RV. All right, you're told just to substitute that in. So body density, you substitute in the RV. The fact whether it decreases or increases depends on your slope. So if we go back to the equation, we can see it's a negative slope. So it's decreasing. But you've got to report the slope as a positive number. All right, so if I lost weight, I don't say I lost -2 kilos. All right, the lost is the negative, the 2 kilos is the amount. Or if you lost money. So let's say, I don't know, someone was gambling and they lost $100. All right, you don't say you lost -100. The loss comes from the negative. So here the decreases is your negative, and then you report your slope as a positive number. You have to have the units. The units are always given to you. All right, so if we can see here, kilograms per litre. The only time they're not, sometimes it's like if you've got days, you know, or time and days, and here we've got centimeters. So usually it's given, the units are given to you. So put those units on. Now you must say for each one, all right, 1 centimeter. So you can't say for each increase, because we're like, well, what type of increase is it? So for each one, and whatever the unit is of your EV. So our units are centimeters. So for each 1 centimeter, that 1 has to be there. And it's always increase. So I saw quite a few students on their tests write decrease there. It's always increase. In the sentence I gave you, I didn't tell you to change that word. All right. So when you get a question like this, you open up your bound book, you look for that sentence, and you just substitute in what it asks for. So the increase stays there. Oh God, sorry, I was meant to rub that out. I don't want to underline that because I don't want to get you confused. And then your EV is here. All right, so the sentence should be in your bound book and you must refer to it. So I'm very surprised 44% got this correct. All right, this should be an 80% plus. All right, because you've got the sentence there, you've got your bound book, there's no reason why you shouldn't be using it. All right, the next one. In this study, the body density of the man with a waist measurement of 122 was this. So this is your actual. Show that when this least squares line is fitted to the scatter plot, the residual rounded to 2 decimal places is -0.02. So they've just given that probably for rounding. They don't want to give you a consequence if you didn't round correctly. They just want to see that you can calculate a residual. So your residual, and this should be in your bound book, is your actual y minus your predicted y. All right, so our actual y was given to us. All right, it is 0.995. All right, so y being body density. So that's why you've got the 0.995 minus the predicted y. So the predicted comes from the equation. It could also come from the graph, but not this one. You've got the equation, use the equation. So you can see here's our least squares equation, and we're just substituting in that x value, 122. Given that it is a show that question, you must show this actual y value and then the calculation for the predicted. Okay, so that must be shown, and then you get -0.02. You can't just write down what this comes to. You must show that substitution into the equation. So 51%, I would say, included students who did not write this substitution. They just did what it worked out to be. All right, and part F was not done well. And it wasn't done well by you guys either, because you got the 0.824, but remember, you've got to decide whether it's positive or negative. So coefficient of determination, that's our r squared value. So remember, your r is the square root of that. Oops, added a 0 in when I shouldn't have. Let me just get rid of that. All right, 6783. But then we've got to decide whether it's positive or negative. Now, you did have to go back to the previous one, and we can see it's clearly negative. So you can look at it whether it's negative on your graph or on in your equation. You can see it's negative as well. So that's why your answer had to be negative. So 26%, and I would say a lot of students forgot that negative. All right, you must remember that. All right, then we've got a residual plot. All right, so you'll notice this often gets asked, does this residual plot support the assumption of linearity that was made when fitting this line to the data? Briefly explain your answer. Yes, as the residuals have no clear pattern or they're randomly scattered. All right, we don't have to go into too much detail. You know, they've given you only 2 lines. You don't have to write a full-on summary. You just have to say there's no clear pattern or they're randomly scattered. All right. All right, moving on to a different exam now. So this is the 2018 NHT. Oh, how many students got that one right? Did I write that? I didn't notice. No. Sorry guys, didn't record that bit. Okay. So we're looking at a scatter plot, shows the weight in grams and the head length in millimeters of 110 birds. Exciting stuff. All right, then we've got the equation of the least squares regression line, and we have to plot it again. All right, so I can tell you the same error that happened before is happening again. You've got to look at your 2 endpoints when you're plotting. So we're going to substitute the 52 in to the equation. All right, here's your equation. You substitute 52 in for head length, and then you get your corresponding y value. So you can see it's somewhere between 65 and 66. So we want a dot there. And then we get the other endpoint, substituting 60 in, and you can see it's up there. All right, you should be able to do that. Then you should have a ruler. I saw so many students on their test not have a ruler. Guys, you need a ruler. Use the equation to predict the weight in grams of a bird with a head length of 49. All right, easy. Again, we're just substituting it in to the equation, so 60.4. All right, is the prediction made in part B an example of interpolation or extrapolation? Explain your answer briefly. All right, so 49 millimeters. That's what we were predicting for. So let's have a look at our data. All right, this one's a little bit easier because our scales starts at 52, so it's clearly extrapolating. And why? Because 49 millimeters is outside the data set. That's all you need to say. And it's your X value outside your data set or your explanatory variable. All right, moving along. I'm just conscious of time, guys. So and you'll see these questions are very repetitive. So when a question's new, I will spend more time on it. When the least squares line is used to predict the weight of a bird with a head length of 59.2 millimeters, the residual was 2.78. Calculate the actual weight of the bird. All right, so your residual formula, so residual equals your actual y minus your predicted y. All right, so it's told us that the residual is 2.78. The what do we want? The actual is what we want to work out. So the actual. And then the predicted is 59. Oh, sorry, it's not the 59. When the least squares line, so we want to calculate the actual weight. When the least squares line is used to predict the weight of a bird with a head length. So this is our X. So we've got to substitute that into our equation to get our predicted y. So let's go back up. So 59.2. All right, just quickly do that. So negative 24.83 plus 1.739 times, and I've already forgotten what it was, 59.2? Yeah, 59.2. So the 59.2 was your head length. We're looking at weight, so we had to use the equation, oh, sorry, that's not right, because it, start again, 78.11. Just because the answer came down on my calculator, which I didn't notice first. Okay, so we want the weight, so it's 78.1188. Now this could be a show that question as well, so you need to actually have this equation and then the substitution of the values. Now it's just a linear equation like you would have done since year 7, so we're subtracting 78.118, so we've got to add that to both sides. So you could do that if you were solving it by hand, but it's not a show that question, so we could just do solve on the calculator. So keyboard, solve, and then you could do 2.78 equals, you can just do x for actual, minus 78.1188 comma x, and rounded to 1 decimal place, you can see that. But you could also just solve it by hand, so 2.78 plus 78.1188, and you get the same answer. So you don't have to go ahead and do that by hand. I would just use solve. If it's a show that question, you should never write calculator syntax or what you're putting on the calculator. It all has to be mathematically. So you can do it like on the side with your calculator, but you're not to write the calculator prompts in the question. All right, Pearson's correlation coefficient R is equal to that. Given this information, what percentage of the variation is, okay. So whenever you see the phrase percentage of variation, it refers to R squared. So sometimes it doesn't explicitly ask for R squared, but when it uses the phrase percentage of the variation, all right, you're only going to really see that when you've got to do the R squared value. The thing with this question is it's saying is not explained. All right, so it can be either explained or not explained. So let's find R squared first of all. So they're giving us R, 0.5957, and we're going to square that value. All right, we don't make it negative or positive because when you R squared is always positive. And then we multiply it by 100 because we do it as a percentage. It is also saying the percentage of variation. So R squared is always reported as a percentage. So we get 35.5. Now that would be a common incorrect answer because we want not. So 35.5% is explained, but if we want not explained, then we just look for the percentage that's left over. All right, so that's where the 64.5% comes from. All right, so if it says not explained, then it's 100 minus your R squared value, and you must do it as a percentage. All right, the residual plot obtained when the least squares line is fitted is there. All right, we can clearly see it's randomly scattered. What does the residual plot indicate about the association between head length and weight for these birds? Basically, there's just a linear association. That's all you have to write. You don't have to talk about it being randomly scattered or anything like that. In fact, you don't want to go on and give more than you need to, because then assessors are like, well, what's your actual answer? So you need to actually just answer the question. So there's a linear association, done, you move on. All right, let's have a look at this one. So the lifespan in years and gestation period in days for 19 types of mammals are displayed in the table below. So we've got lifespan and gestation period. So remember, I think the very first question is name the explanatory variable. So you could think about your variables. So you might be thinking, I don't know what gestation period means, and what's lifespan. Okay, so lifespan is how long you live. So this is for a certain type of mammal in years. So gestation period is basically how long you're pregnant for, or the mammal is pregnant for. So let's say you didn't know what those two variables mean. In this statement here, in the stem of the question, it actually tells you what the explanatory and the response variable are. So a least squares line that enables lifespan to be predicted. So what you're predicting is your RV. All right, because remember we go y equals. All right, this is what we're predicting. Always the y or your response variable. Whoops, turn that into a predictum. I hate having spelling mistakes, so I'll just change that to an I. All right, so you're always predicting your y, your RV. All right, and then obviously the other one is going to be your EV. So explain the explanatory variable, it's gestation period. So this is your X and this is your Y. All right, now with part B, you have to do the least squares line in terms of lifespan and gestation period. And we have to do it to 3 significant figures. Now, I'm not going to go ahead and put this in my calculator because it's going to take me a long time, but you know how to do it. So you should have gestation period in list 1, Y in list 2. In a different video, I did explain that having your, where am I? Oops, wrong one. Having your, no, that's not what I wanted. Sorry. Statistics. You can have your columns already set up as X and Y. All right, instead of lists. I would encourage you to do that. It just probably makes, especially if you get confused between list 1, list 2, etc., etc. Just have them already labeled before your SAC and before your exam. All right, 3 significant figures. So we've got 7.58. So remember, significant figures is not the same as rounding. If you get stuck, you can use the S round function on your calculator. So perhaps go ahead and have another go at doing that one. You probably already still have the values in your calculator. All right, so if you got your, and I still mark this wrong for this question, but on your exam, they're a little bit more forgiving. So if you did write lifespan here and you then went on and calculated B correctly and C, then they would have given you the marks. All right, and then the correlation coefficient, again, once you get your equation, you get your R value as well. So if this was done correctly, that's 4 marks. All right. There should be no reason to get that wrong. All right, so just taking your time to think about the explanatory variable and then you're putting it into your calculator. Making sure you round properly, all right? Your calculator can do that as well. And then your R value, you're just reading that off your calculator. It does say 3 decimal places. All right, different to 3 significant figures, but you can see it's the same as 3 significant figures anyway. All right, question 4. Oh, we've got another graphing question. So the scatter plot below plots the variable lifespan in years against the variable sleep time for 19 types of mammals. All right, this one does start at 0. All right, so probably should have been an easier one to sketch. All right, so we're going to be sketching this equation. So 42.1. So you kind of want to make sure it's between the 42 and the 43. But a lot of people got the end point incorrect. So all you need to do is substitute in 18 here, and that would give you this point. It's a bit annoying that we don't have the dotted lines going across to help us. So that's why you should have a ruler, all right, to help you with that sketching. You've done straight line graphs since year 8 at least. All right, part B, describe the linear association between lifespan and sleep time in terms of strength and direction. So they've given you the coefficient of determination, all right, which is R squared. You can use that to find R. So just going on the calculator. Square root of 0.416. All right, and we get 0.644. So coefficient of determination is R squared. It's a lot of it's just a lot of language. So making sure you've got it in your bound reference is extremely important. So we get 0.6 it doesn't really matter what it is, 6, 4. Maybe I have to answer it later. But we can see it goes down, all right, both on the graph, we drew the graph or the scatter plot, so it's going to be negative. So interpreting your R value, you should have that in your bound book, and it's negative. So moderate and negative, 2 easy marks. Look at that, 2 marks for that. All right, interpret the slope of the least squares line. All right, here's another interpretation. This time I think they only gave 1 mark before, 2 marks here. So again, you're just substituting in. So on average lifespan, that is your RV, your slope is negative, so it's decreasing. What your slope is, 1.9, and the lifespan is in years. So lifespan decreases by 1.9 years for each additional 1 hour. So remember, you've got to have that 1, and whatever the explanatory variable is measured in, it's measured in hours. So 1 hour of sleep time. So you need that 1 there, even though, yeah, so what I've got in here is additional, so that also means increase. I just realized it's not exactly the same. I think I copied my answers from the examiner's report. So additional does mean to increase. You can go rogue and write your own statement. Doesn't have to be exactly as it is on the assessor's report or in your textbook or in the notes that you've been given, but it still has to be correct. So it's just easier to use what's been given to you and just changing your words. All right, interpret the coefficient of determination in terms of lifespan and sleep time. So the interpretation of R squared should also be in your bound reference. And again, you're just replacing numbers. So we always do it as a percentage. So your R squared value, all right, times it by 100 to turn it into a percentage. And then we've got of the variation in your RV can be explained by the variation in your EV. So just 3 things you need to fill in for that sentence. All right, so pretty straightforward. The lifespan of the mammal with a sleep time of 12 hours is 39.2. Like when I read this, I'm like, they're asking for a residual. Show that when the least squares line is used to predict the lifespan of this mammal, the residual is 19.9. So again, it's a show that question. So just reading through, remember your residual is your actual Y minus your predicted Y. All right, so spend it with sleep time of 12 hours. So they've given you the actual, which is 39.2. So you can see I put it in there. And then this is what we're going to be predicting for. So we substitute that into the equation. So the equation was given to you up here. All right, yeah. All right, so substituting them in, we need to have this part here. You just can't go straight to this second line. And if you didn't get something other, if you got something other than 19.9, don't think the exam or the SAC is incorrect. All right, you've probably made a mistake. All right, and we're done. Bye guys.